Okay, today is our second day of looking at thermal energy. I want to remind you that heat refers to the energy that enters into the molecules of a substance based on a difference in temperature. The heat can go into the material or the heat can come out of the material. If you have an appliance like a hair dryer, the power will tell you how much energy is being generated each second. So in this case, it's 1875 watts. That means 1,875 joules every second. Okay, so remember that. So today we'd like to talk about how much does the temperature rise when we add energy to an object. So if I had a container of water and I add a certain amount of energy, how hot is the water actually going to become? So it depends on three factors. Factor one is how much energy in the form of heat do I actually put into my system, into my material. Number two, how much material is there in terms of mass, in terms of kilograms. And the third factor is the type of material that you have in your beaker. Some materials get hot real quick and other materials are going to take a little bit longer to change temperature. On your reference sheet, if you can find your thermal reference sheet, you want to be looking at this column that mentions specific heat. Specific heat goes by the letter capital C, and bigger numbers mean it's harder to change the temperature. So for water, it takes 4,190 joules to make the temperature of 1 kilogram go up by 1 degree Celsius. Then if you take something like lead, you'll see that lead only requires 130 joules to raise the temperature by 1 degree Celsius. Metals get hot quick. As you can tell, if you ever put an empty pan on a stove, it's going to get hot really quickly. And water takes forever to raise in temperature. Okay, so how do we actually calculate it? So we start with the energy that we added. That was factor one. We look at the mass of material that we're trying to heat up. We take the specific heat of that material, and those three factors will allow us to predict the change in temperature. Okay, so it depends on how much energy, how much matter, and what is the material. Those things combined will let us find the change in temp. So try one. We have a hot plate that is going to add 25 kilojoules to the water. It is 160 milliliters. I hope you remember from chemistry that for water and water only, a milliliter equals a gram. So that's 160 grams of water. We want to know the temperature rise. So we do the formula. We put the 25 kilojoules. Make sure you put it into joules. You use the specific heat of water. You use the mass in kilograms. And you solve for your delta T. That will come out in Celsius, and make sure you box it off once you get an answer. Okay, so this is how we find the change in temperature. Now let's do it again. But this time, instead of adding the energy to water, let's add it to sand. As you know, when you go down to the beach, sand heats up a lot quicker than water does. You step on the sand in the summertime and it's really hot. You step in the water and it's much cooler. Okay, the reason is sand has a different specific heat. So I'd like you to repeat the problem, but this time we're going to use sand, and we're going to use 160 grams of it, and we're going to add the exact same amount of energy. For sand, you don't have it on your reference sheet, it's around 840, so much lower than it is for water. Okay, I'd like you to try one where instead of giving you the energy, a more realistic scenario is where you know the power. So the power is set at, let's say, 450 watts. I have 600 milliliters, so that's 600 grams of water at 15 degrees Celsius. I want to get the water up to 80 degrees. Maybe I'm making hot tea. I don't want it to actually be boiling, but I'd like it to be hot. And I don't want to have to sit there and wait. So I want to know how much time can I expect to wait. All right, so the way you're going to do this, Q equals Cm delta T. Find your Q, and then use your power equals change in energy over time. You're solving for time. You should have all the information you need to get the Q, and then you should have all the information you need to find the time. Okay, and that is where I'd like to stop for today. I hope you guys understand how you find things like power or energy or time or specific heat or change in temperature depending on the scenario. Again, make sure you know that different materials are going to change temperature more rapidly or more gradually based on their specific heats.